When you're building a top-down game, you might want to have different animations for your Sprite animation component in Flame. Sprite animation component has a property called animation. In your onload method, you can create different animations and then change the animation, such as, for example, you could call the animation run, or you could call the animation idle. You can change the animation when a condition takes place, such as you press a button or you press a portion of the screen, in this case, to change the direction. When the direction is changed, at that point, you change the animation. So something that you might do, for example, in the update method, where a certain condition takes place and the direction changes. The main concept here is that the animation itself is a property of the Sprite animation component. So in the onload method of Flame, you would create some different animations, and then when the condition hits, then you change it. So let's create a new project called George. I'm going to run mine on Windows. You don't need this platforms. I just have the platforms because I want to reduce the size of my project. Okay, we've created the George project. And then I'm going to create a directory for assets images. And we'll move George into you can also use File Explorer for this step. So George is in there. He's in my project. I'm going to add Flame to the project. Okay, Flame's added. I'm going to start up VS Code. I have the Dart and Flutter extensions already applied to VS Code. VS Code is here. Although I've added George to the asset, or George's sprite sheet, you won't be able to access it. So in the pubspec.yaml, we need to give the game access to the assets/images, and make sure you have the slash at the end, or otherwise you'll get an error. In the lib, we're going to delete everything. We'll start off with a new class. Let's call it my George game. Extends Flame game. You need to import the Flame game right here. For the run app, it'll be a game widget, which is from Flame. Then we're going to pass it the instantiate value of my George game. And it should be all black here. Okay, it's all black. This is what we want. We're going to start placing the sprites on it. We're going to load the sprite sheet in the onload method, which is built into the Flame game. The onload method is a future, so we're going to do future void. Make it async, and we're going to wait for the sprite sheet to load. So it's a method. So first we'll just run the super for the onload method. Then we'll load the sprite sheet. The sprite sheet accepts an image. We have to wait for the image to load from the local storage. So the sprite sheet is a final because we just load it one time and then we manipulate the graphics on there. So it's going to require the parameter for an image, and we'll load it. So we'll start off with await. then it's images.load, and the name of the file, assuming you have it in assets/images. The source size is the size of each cell on the sprite sheet. So how do you know the size? Well, it may say at the site that you downloaded the sprite sheet from, or you could open it in some type of image editor. I'm going to use GIMP in this case because I'm actually going to edit the sprite sheet a little bit later in the tutorial to make it easier to load the sprites. It is 48 by 48 pixels, so if you don't want to follow along with the GIMP portion of the tutorial, it is 48 by 48, and you can download the actual sprite sheet after I edit it from Teachable, which is free. Or you can go to the GameArt site and grab it. I'm going to configure the image grid as 48 by 48. Just by looking at it, you can see that it's generally 48 by 48. Okay, so I have the grid up. You don't need the grid, right? This is just to visually see the each individual sprite on the sheet. All you need is those two numbers, 48 by 48. Then I'm going to create 5 separate animations. Starting off with one. So the first one is the type is Sprite animation, and we'll go for the down animation. And I thought that the sprite sheet was actually arranged differently when I downloaded it, but I think what I'm going to do is I'm just going to change the order of the columns and the rows manually. I'm sure there's a fancier way to do this, perhaps even within the program, but this was relatively fast for me. So I created another blank sprite sheet, and then I'm going to copy and paste each of the cells to change the order of the columns and the rows. I already selected George, and I kind of like the name. I kind of like the look of the sprite character, so I found it a little bit almost meditative to copy and paste the cells in here. So I just went ahead and moved it one cell at a time. It's kind of relaxing to do this. So if you're looking for your own sprite sheet, it might be easier to get one where the animations are across in a row. And if somebody knows how to do this in Flame, just drop a comment below. In this case, I found it somewhat relaxing to just move these characters around. The sprite was pretty cute anyway. But now I have the entire sprites, all the sprites for all the 4 directions in, and I can start creating each individual animation. So there will be 5 animations. There will be up, down, left, right, and idle. A step time of 0.5 here is going to be a bit too slow, but we can speed it up later. I like to start off with a slower animation just to make sure the animation is working, and then speed it up to the desired effect. There's a keyword 2 on the create animation, and that's the number of cells or animation cells in that row that's specific to this animation. So there's 4 cells, so we'll specify 4, and then we'll create the rest of the animations for George. George will have 5 animations. So I'll just copy it from the line above, and I'll change the name, and did not declare the left animation yet, so we'll have to do that. It'll be another late, so we'll just copy the first one. We'll actually create 5 animations. I'll do the idle one last. So down, left, maybe up, right? Should be. This order doesn't matter. This is just trying to match up the variable so I don't get confused when I attach it to the sprite sheet. Okay, we got our 5 animations declared, and now we just need to load the proper cells for each animation. So I think rights is the row 3. Row 0 is the first one. It's a list, right? So then I'll create row 2, which is down. Oh, up, yeah. Just make sure that you've attached the right name, human readable name to the animation. Now create one for idle. It's basically George isn't moving when he's at idle. I'm just going to grab the first row. Actually, you don't need the 2. It's not required, I think. I'll just put it down for consistency. I think it's optional. So we've got all the animations. The key concept here is that the animation is a property of the sprite component. So although we have the animations, we don't actually have the sprite component. So let's create the sprite component. I'm going to call mine George, the author of the sprite sheet. I think he called it George. I don't think that's his name. So George, the sprite animation component, is basically the same as a sprite component. So we can apply all the methods. Whoa. This should be George equals sprite animation component. And after you instantiate it, that's when you can apply the different things to it, like the animation. So let's start George off with a down animation, just to get some motion going. If it's an idle, you can't really tell whether he's moving or not. So probably when you start the game, when you actually build it, he's going to be idle, right? Or your character will be idle. And then the player takes some motion and the character starts moving. But for now, let's make George going down. He's actually not going to move on the screen. He'll just be animated in one place initially. We'll make his size big, so it's easier to see the animation. I'll make him about 300 pixels. He'll be humongous relative to the size of the game screen. And then let's add George. George, we put a lot of work into George to get him to this point, and hopefully George will come to us. He'll come to the party. George is not there. Oh, there's George. Maybe just restart the game and reload it. George is looking pretty good. I'm going to adjust George's position a bit. George. Okay. Maybe let's make him 100, because it's the left, it's the top left corner, the anchor point, right? Because it's the default anchor point. Yeah, George is looking good there. So We'll leave George at that position. It's probably traditional to have the directions be right, like a string, right, left, top, bottom, idle. I'm going to use a number for the idle, and the rest of the directions. So George is idle now. We just changed it manually in the code, but we're going to set up different directions for George from 0, 1, 2, 3, and 4. So 0 is going to be idle. We'll initially start George off as idle, and then we're just going to increment the direction counter every time you tap the screen. To keep the tutorial simpler, there's no direction based on where you tap the screen, and there's no virtual joystick, no keyboard input. So imagine that it's an arcade game and there's only this one button. All you can do is press the button. So we're going to use the game screen itself as just this giant button, and every time you tap it, it's going to increment the direction, which will be an integer, and that will change George's direction. So initially George is not going to be moving around the screen, but we're still going to change the direction of George within the update method. The update method is built into the Flame game. So pre-existing method, so we're going to override it using the override decorator. And we'll run super.update as the first command. Then we're going to use a switch statement, not a case. I got confused. It should be switch as the first word. And the confusion continues. So we'll start bidding up the cases and use the different cases, 0 through 4, to switch the animation. So just remember, the key concept is that the animation is a property of the animation, the sprite animation component. So if it's case 0, we can just set the animation property to the idle animation. So that entire animation is just one property. It's pretty cool. So in case of 1, we'll set the animation to, what did I say? Down. Okay. And then in case 2, we'll set the animation, I think, to left. I'm going to have to look again. So that animation name is the name of the animation that we created earlier in the onload method. Case 3, it's got to be up. You know, I should have probably copied that comment earlier to help my memory. And then case 4 is right. The main idea here is that based on some type of trigger, the character's direction will change, and then you can change the animation when the character direction changes. So in the theme of our simple demo here, we just have that one action. So we just use a tap detector mix in on the Flame game. And with that tap detector, we have access to the method onTapUp. So when you hit the mobile app screen, you tap it, we can then take an action. It's built in, so we're going to have to override it with the override decorator. And then we can grab the info where we tapped, but we're not going to use it because for simplicity, we'll just take anything, any type of tap. And I think initially I'm just going to print out that a tap was detected. So put a print statement to help with the debugging if there's any problems during the development of the game. I'll just put the animation should change, so change animation. And let's run it. And the tap is working. So let's go back and change the case now, the direction. Because I'm just tapping the entire string, I have access to the direction variable. So I'm just going to increment it. So it's a loop, right? So every time you tap on it, it's going to get higher. And at some point, it's going to get higher than 4. But if it's higher than 4, so if it's 5, we'll set it back to 0. So it's only 0 through 4 are the valid numbers for the direction of George. George starts off at idle, but if we tap on George, George starts walking. And we tap again, he's going to cycle between the 4 different directions that we've given George, plus the idle state. George is working, and I kind of like this one tap to control the game. Instead of tapping like the 4 different edges of the screen, maybe we use this type of control. It's more simple. If there's just one, I'll probably make a button, right? Some type of I don't know, just round button for simplicity. But let's increase the speed of George, because at 0.5, he looks just a little bit too relaxed. And he may never get to his destination, wherever he's going. So we'll set the animation speed as a variable that we can reuse. So if we want to change his speed, we can just change that 0.1 up at the top. Let's see how George is doing now. George looks busy. George looks very industrious, like he's going to go someplace. Go, George. In fact, George looks so industrious that I think we need to make him move around the screen just as a reward for his hard work and efforts. Go, George. So before we make him move around the screen, let's make George a little bit smaller, since at the size he's at, his world is just too small for him relative to the size of him, and his head is huge. So we'll make the character size maybe 200. I think it was originally 300. So he'll be just a bit smaller, but big enough for us to see. Okay, he has a little bit of, well, he sure is busy. He has a little space to walk in. And we can give him just a little bit of movement here. So no gravity, no momentum. We'll just move him by 1 pixel at a time. Oh, George is moving down. He looks quite fast. Okay, let's give him the ability to move in all directions. So if George is going left, the x coordinate, which is the left to right axis, we'll just decrease it by 1. And if it's on the up, it's the y-axis. So 0 is at the top, right? So the smaller the number is, as close as possible to 0, the higher George will be. And for the right movement, the left edge of the screen is 0. So the higher the number, up to the width of the screen, which you can get by size 0 if you wanted to do bounds detection. We can also apply a camera to George so that the world around him moves with George, but It just gets more and more fun and more complex. You can just stay here for days building up Georgia's world. So I do have some tile map with building the maps with tile D, or you could use a standard image as the background for George. I'm almost tempted to put it in right now, but maybe I'll save that for a future video. Have a great day. Subscribe to the channel for updates on the more than 50 videos I've made on Flame. The videos with source code are also available for free on Teachable, 100% free course if this is a hobby. In whatever way you choose to learn, make sure you have fun and unleash your creativity. Have a fantastic day.